SPSS review session, mechanical knowledge. Does anyone having trouble finding? You're not having trouble?
I haven't downloaded it. It's like viewing. Yeah, it's like view file instead of that.
That's
Oh, I think that's copy.
okay, so one of those should say like download as or something.
Okay.
Do you see it?
Yeah.
Okay, and then that should let you save it somewhere. Okay.
What does text qualifier mean?
Is that on here?
On my screen it says with a very old version. No, that's that.
Oh, okay. Yeah,
Yeah.
this is very old. I'm not sure what the text qualifier is.
We
This
can
is
go
this
down.
is the data preview.
Yeah, it looks
So
nice.
what happens if we start done? Does it change it?
Okay, let me.
That's
Yeah.
fine. It puts quotes around the names of our variables,
Okay.
which doesn't really matter. I think just leave it whatever it's defaulted to. But what's important is that it knows that we're using comma separated,
Yeah.
which mine doesn't even, oh yeah, mine does say delineator. Oh, and mine does say text qualifier, double quote. Anyway, the point is that the default options are fine. I've intentionally given you guys a data set that will read in with the default settings. So push finish, and that should work. I'm a little older than you guys. I'm pretty sure that's the version I was using in undergrad, so it's a little dated.
It's the one we get free at our university. So.
Well, nice. No, that saves you hundreds of dollars. And you have a perpetual license for it? Like, you don't need to renew it every year?
I think it's, let's not talk about it.
That saves you hundreds of dollars.
Yeah.
Okay, so is everybody at least this far? Yes? I should ask things in the negative. Does anyone need me to wait? Okay, so once you're here, just go ahead and push OK, or if you're on an older version, push next, 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 OK. And then you should get something that looks like this. True? Did anyone get anything different? I'm just going to double check my email, see if there's that student that was supposed to join us online. I don't know what happened to her. Set up Zoom just for her. Okay, is everyone good? Aren't you? Are you good? Good. All right, so we should have two tabs. Everyone should have two tabs. One says data view and one says variable view. I'm assuming that we need a refresh of everything, but don't, if I'm boring you, I apologize, but right, we're here to review. So if you guys go to variable view, which is this second tab at the bottom, you guys will see this assortment of information, right? So we have three variables, and this will be redundant in the PowerPoint once we get to that, but that's okay. So we have three variables. The code variable tells us our different groups that we have. If we went back to data view, we would see that it ranges from 1 to 2 to 3, right? So we have three different groups. One is in alphabetical order, bikers, the second is pilots, and the third is truck drivers, right? So a 1 denotes bikers, a 2 denotes pilots, and a 3 denotes truck drivers. Now SPSS is kind of neat because we can actually store those value codes right inside SPSS if we want to. So under values, if you click on it, there's this little ellipsis that will pop up. If you click on that, then you can enter value codes. So if we say a value of 1, I'm going to give a label of biker, right? And then push add. And then you can say a value of 2, I'm going to give pilot, right? And say add. And a label of 3, I'm going to give, I don't remember what, trucker, right? And then if we push OK, that'll store those value labels for us. Other things that are important to note, most of the time SPSS is pretty smart. So under these measures, under the measure column, it's thinking that this code variable is nominal, which in fact it is. I got that one right, because this is a variable that is in name only, right? There's no meaningful difference, numerically speaking, between truck drivers and pilots, right? The numbers that we've given it are, we could have given it 3,000,000 and 4,000, and the math would work exactly the same because these are factors. The value we assigned 1, 2, and 3 doesn't actually mean anything other than that they are different. Okay, and then for age and score, it is assigned a level of scale, which is what SPSS uses for any continuous variable, right? And that's also appropriate here. Age is a continuous variable, and we are believing that our score on this test is also a continuous variable. So the defaults here are fine, but just be aware that sometimes you may need to tell SPSS that a variable is actually a scale variable because it may not believe you when it first reads it in, or you may need to change something that it thinks is scale to be ordinal, for instance. Oftentimes the worst, if you have like a Likert scale, sometimes it'll think that that is a nominal variable, right? Because it doesn't actually have a whole lot of categories, but you need to be able to treat it at least as ordinal in order to do any data analysis on it. Otherwise, SPSS won't let you run things because you can't run anything with a nominal variable. So just something to keep in mind. Okay, I think I've hammered that point to oblivion. So the first thing we're going to do, let me just catch my PowerPoint slide up. Already did that, already did that, already did that. Okay, we have 3 variables, at least 3 categories in our code variable, right? And we've just gone through and told SPSS what those are. And age, which is another variable in our data set, is, as it sounds, the age of the examinees. And then we also have their score on this test of mechanical knowledge. Okay, those are the variables that we have. We've already added codes. Sorry, just catching this one up. So we're going to run a one-way, we're going to run ANCOVA. So ANCOVA, as you guys probably remember, is basically an ANOVA with a continuous covariate thrown into it because we want to account for that. So say that we believe that our 3 different groups will differ on this test of mechanical knowledge, but we believe that the participant's age is somehow related, right? As people get older, they generally learn more. So we want to make sure that we've accounted for age in our study. So we're going to include this continuous covariate, age. So I'll go back to SPSS. So the way that we would run this in sort of standard SPSS dialogue is you'd go to Analyze, and you would go to General Linear Model, and you'd go to Univariate. Okay, now dependent variable, that's going to be our score, right? That's the test score that we're interested in. And age is going to be our covariate, right? And then our fixed factor. You guys okay? It's a small enough class I can stop.
Yeah, but
no. I can wait. Do you want to just wait a minute?
No.
To see what happens?
Just go ahead.
You sure?
Yeah.
Okay. All right. Okay. And the code variable, right? That's our factor. Those are the things that we have told separate our groups from each other, right? Okay. So we could just run this like this. This would run our ANCOVA, but there's slightly there's a few steps we could add on to this to sort of get a few bits of information you'd probably want to know. One of the things that people often are curious about, if you ever submit something for publication or in a class, people will often say, did you test for homogeneity of the regression slopes? That may be something you guys have heard about, right? You want to make sure that the covariate is the same for all of your different factors. If it's not, then ANCOVA is probably not the method you want to be using. So SPSS does not do that by default. We can make it do it for us there. So if we go to model, and if we go to custom here, what we need to do is we need to add, we're going to add all of these into it. We're basically saying, hey, I want all these. But then if we select code and age together, right, and then make sure that this says type interaction, and then put that in there, that'll create an age by code variable. You guys with me?
Mine says the terms.
Sorry, you have to put custom?
Yeah, mine doesn't
Okay,
have
let me see.
terms.
Sorry.
It's like the terms.
Yeah, I think it's the same thing. And then I did a select. And then we're going to push continue. And then we're going to go ahead and push OK. So this is our output, right? I don't know. I assume you guys have seen SPSS output before, but I'll go over it just for sake of argument. So it's probably easier if I don't stand in front of the projector. I guess I can use this. So here we have that interaction term we were talking about, and it is not significant, which is what we want. We don't want groups to be different on the covariate. So the first thing that I'm going to do is I'm just going to go back and rerun the model without that covariate in there, or sorry, without that interaction in there, which won't change the model much, but it will change the model. Sorry, push the wrong button there. I think if I just change it to full factorial, it'll take that out of there. Yeah, so that's not there anymore. But our covariate still is, and we can see that our covariate is not significant, right? I'm going to leave that in the model. It won't mess things up too much. It's always a debate of whether or not you leave a non-significant covariate in the model or not. It sort of depends on what you're trying to do with it. But we know that our covariate is not significant. And this is the ANCOVA itself. So this is our omnibus test, right? Telling us if there's some group difference somewhere in there, right? Do our groups differ somewhere? So they do, and this is the F statistic for that. Questions so far? Okay. So we just ran an ANCOVA. Yay, you guys are doing great. If we don't have any questions, then I'll update the PowerPoint, just make sure I'm not skipping anything. Yep, we did that. Yeah, interaction's not significant, so we take it out. Here we are. Okay, so one thing we might want to do are some contrasts, right? You guys remember doing contrasts? Whenever you have the omnibus result, sometimes you're interested in going in and saying, okay, I know that there's some difference somewhere, but where is that difference, right? So the simplest way to do that is by doing what's called simple contrasts, and that's what we'll cover today. So if you guys go back to General Linear Model under Analysis and go to Univariate, we can click on this Contrasts button, right? And right now we can see that it's not doing any contrasts, which is why we didn't see any in the output. But we can change that. So if I click under Contrasts and just go to Simple, it's going to ask what my reference category is. So there's lots of different ways to do contrasts. In the simplest version of it, what we're going to do is we're going to compare every group to a reference group, right? This works really well when you guys have a reference group in your experimental design, right, which you might call your control group, and you're comparing everyone to your control group. That's sort of what this is designed for. Let's just pick, let's say that we want to compare everyone to truck drivers, okay? So, well, I think in the PowerPoint I compared everyone to bikers. No, I did truck drivers last. So truck drivers are variable 3, okay? I'm just trying to stay consistent here. Truck drivers are variable 3, which is our last category. So we're going to say we want to compare everyone to the last one, which is what's defaulted here. And you actually have to push change to update this. So now it says code simple, so it's going to do a simple contrast analysis.
But what if we like to have the second category, the contrast on the second, because we said first and last one?
Yeah, I don't know why it doesn't give you more options. That's a really good question. I guess you could go in and recode things in the worst case scenario, which is annoying, but I agree. I don't know of a way to do it just from here. What I do know is we're about to cover dummy coding, and when you dummy code, you're entirely in control of how you code things. Yeah, so we can do it that way. But in this menu, I'm sorry, I just don't know. So good question. So I'm going to push continue, and we can go ahead and push OK. And so this will give us, in addition to our overall test results, which we already knew, those won't change, right? Because what we're doing is a sub-analysis after those results. So these results are identical. Then it's going to go in and do our comparisons, right? So level 1 against level 3, level 2 against level 3, because we told level. Oh, I see what you're saying. You could run this and then run the other one, and then you would have all of them. Yeah, that's a good point.
That only works with 3.
Yeah, but it's a good idea. Thank you. Okay, so these are our results, right? So somewhere in here, there's a significance test. I don't know why I just get this. So right here, right, this tells us that there is a significant difference between level 1 and level 3. And again, there is a significant difference between level 2 and level 3, right? So this actually tells us the direction of the effect. So in both cases, it's telling us that level 3 truck drivers are lower than the things they're being compared to. So it seems like pilots overall have the highest score. In second place are bikers, and in third place are truck drivers. Now I made this data up, don't write a paper about it. Okay, is everyone good here with me so far? Okay, all right, so I'll just update the PowerPoint real quick. So we've gone through and we've done an ANCOVA. We've made sure that we have homogeneity of the regression slopes, and we have done a contrast analysis. You guys have covered pretty much everything you would have done in an ANCOVA class in like 20 minutes. So
the homogeneity of the slopes.
Yes.
The interaction.
That's right. That's exactly it. And you know, this isn't meant to be a full review of ANCOVA. I'm saying that a little bit tongue in cheek, but hopefully this stuff is familiar to you guys. And I was trying to give you material that really is just below the level of what you guys are learning in 905. So hopefully it's a good jumping off point. Okay, so hopefully someone at some point said to you, ANCOVA and regression are really just the same thing. Maybe. If not, then I'm here to tell you, ANCOVA and regression are really just the same thing, assuming that you code your variables right. If you dummy code your factor variables, then you can run them in a linear regression model. You will get identical results to an ANCOVA. When we cover our supplemental section on matrix algebra, which will probably be in 2 to 3 weeks, I'm currently planning to sort of show this in matrix form. That'll depend on what the interests are. So anyway, if you're interested in sort of the more theoretical development of this idea, we can do it then. But right now, you'll have to take the computer's word for it, because we're going to sort of demonstrate that it's true. We're going to do a dummy code and see that we get the same results. So, any questions? Okay. I'll go back to my SPSS. So if we go to transform, there's 2 different ways to do what I'm about to do. You could say recode into different variables. It's maybe a slightly faster way to do it, but I'm going to do it this other way, because this way it's harder to screw up, because you don't want to accidentally recode into same variables and change one of your existing variables. So if you go to compute variables, basically what we're going to do is we're going to make 2 new variables. Remember, when you're dummy coding, you need, for the number of variable codes you have, you need to create that many -1 dummy coded variables, because one of those variables will be your reference, and so it doesn't need its own variable. Cool. So basically what we're going to do is we're going to make a variable. For consistency's sake, at least in the PowerPoint, I was planning on comparing everyone to truck drivers again, but would you guys rather use a different comparison? Okay, we're okay using truck drivers? Okay, so that means we need to make a variable for bikers. And basically what we're going to do is we're just going to take this code variable, and we're just going to make bikers equal to code. We'll see why in just a second. Just trust me. And go ahead and push OK. That'll create that variable. And then we're going to create a second variable, one for pilots. That's also going to be equal to code. And we'll say OK. And then what we need to do is we need to recode those variables that we just made. So, sorry if you guys didn't see that. Are you guys with me?
Yeah, having trouble spelling pilot.
Hopefully I spelled it right.
Are we also doing the third one?
We will not do a third one. We only need 2, because we have 3 categories. So we only need 2 dummy codes. So once we have those, we're going to go to transform, and we're going to go to recode into same variables. And we're going to recode the variables we just made. So we're going to take bikers, and then we're going to say old and new values. Everyone good so far? So basically what we need to do is we need to say, okay, we already know how the code variable is coded, right? Bikers were number, it's alphabetical. Bikers were number 1. They were 1. Pilots were 2, and truck drivers were 3. So what we need to do is we need to code bikers to still be 1, but make sure that everything else in this dummy variable is 0. So we're going to say values of 1 are still 1. We're going to add that. Truthfully, you could skip that part, but for completion, I'm adding it. If you didn't tell it to recode 1, it would just leave 1 alone, which in this case would be fine, but sometimes it's best just to make sure that you've exhausted all the possibilities so you don't forget something. And then we're going to say values of 2, I want you to become 0. And values of 3, I want you to also become 0. To do what?
To do all other values.
Where is that? Maybe. Let's see what happens. That's a fun idea. And then we're going to go and push OK. So that'll recode bikers. And then we're going to go back in and transform and recode into the same variables. And this time, instead of bikers, we're going to do it for pilots. And I'm going to delete these because they're not right. So you can remove them all. Again, there are faster ways to do this, but this one is sort of the most comprehensive way to show. So this time we're doing pilots, right? So pilots are coded as 2 currently. So 1 needs to go to 0, right? And then 2 needs to go to 1. And 3 needs to go to 0. You guys with me so far on why we're doing this? Do you guys remember dummy coding? Do you want me to talk about dummy coding a little more? No. Okay. All right. So I'm assuming we're good then. And if we push OK there, that'll recode that variable. So now we have a dummy code for our bikers and our pilots, and the information for the truck drivers is contained within those 2 variables because they are 0 in both. So they are the reference category that we're comparing against. Okay. So then, if we go to analyze.
Essential. I need to change it because scale on it. Yeah, okay.
You're good?
Yeah, thanks. Sorry, it just had scale and not nominal measure.
For the variables you just made?
Yeah.
That's strange. Yeah. I think, yeah, I don't know how it would run it if we didn't tell them they're nominal. So yeah, please change those. Mine did by default, as you guys can see here. So, I use R for most of my analyses, and what's interesting in R is for some variables you have to specifically tell R that they are factors, which may be the same thing that SPSS does when it knows that a variable is nominal. So it's possible that it would run it wrong if it didn't know that it was nominal. I'm not sure, but always better to be safe than sorry. So anyway, if you guys go to Analyze and go to Regression, Linear, and then we're going to make our dependent variable the score on the test, right? And our independent variables are bikers and pilots and age, right? Now regression is nice because we don't have to try and think about what our covariates and what our factors are, because everything just goes in as a variable, right? And then that should be all we need to do. So if we push OK, then we get these results. And so I'll pull this up in the PowerPoint just because it's easier to see there. But, whoops, except that I went too far. Let's see if I can not go too far this time. Okay, so on the left are what we got before, on the right are what we got now. Does this look right? I'm not actually looking at my machine, but this should be identical to the results you guys are looking at. So we can see that our F value is identical, right? That's a good sign. That means that we didn't leave a variable out or something strange. significance should be identical, right? And our contrasts should also be the same. So what do we have? So this gives us our standard errors. So this is the difference, 9.188. That's the same here. The standard error of 0.713, right? That's the same. 29.526 with a standard of error of 0.715. That's the same, right? These are significant, just as they were here, and age, not significant, just as it was here. So we've reproduced the results identically. So anyway, the hope was that this would help hone your SPSS skills, or at least refresh your memory on them. But also this just, if you hadn't seen the dummy coding approach to ANOVA or ANCOVA before, this just gives you another tool in your toolbox to be able to approach these sorts of methods with. Do you guys have any questions? That's more or less what I covered today, because that is, I mean, as I was saying, those are the sorts of analyses that you would have been expected to have done before now. We've done a regression, we've done an ANOVA, we've done more than that. In fact, we did an ANCOVA with a couple of different variables in that. Are there any other kinds of analysis that you guys want to see, like a standard t-test, or I mean, an ANOVA without a covariate would look exactly the same as we had it today, just without the covariate. Seriously, guys, questions? I appreciate you guys coming. Hopefully this was useful.
I just don't have specific.
Okay. Yeah. And don't feel obligated. Just, I want to be helpful. So, if you guys don't have anything, though, I don't have anything else prepared. I thought this would be a good coverage. So hopefully it was useful.
On the project, do you think we could also use R, or?
Yeah, if you want to. Yeah. You just need to make sure that you explain your findings, and if your output isn't very clean, then you may want to clean it up. Right? Sometimes our output seems like things are great. Not that SPSS is, but people are more used to looking at SPSS. I'll be grading, so I can say definitively that yes, I'm okay with R. But yeah, under those caveats, make sure to tell me where in your output I should find the results, and make sure that they're useful.
Regarding the projects, there will be some information coming. I don't know because does it anything? No, I don't know.
Did Dr. Brochu say there's 4? Did I hear him right?
5.
5, including the final project? That's separate from the final project. Okay. I know. Great. I think the first project is going to be on the Italian's T-squared, but you might have something further than that. On your guys' syllabus, next to certain topics, there's an asterisk, and then maybe he's already said that's the things for which there will be projects assigned. So until whenever that first one is, there won't be any projects, and I think it says on T-squared, so you guys still have another week or two before to start covering the topic that I was saying. I'm not in charge of writing the first one. I gotta offload that. That's on Dr. Progio, so I don't know when he'll do that. Sorry.
And we get a data set, or is it?
Yeah, he'll give you a data set and some research questions, and he'll say, answer these questions. And so it'll sort of be up to you to use what methodology you think is most appropriate. Sometimes it'll be post hoc tests that are indicated, right, like contrast or something like that. It depends on what the specific topic is. But generally, the hope is that whatever answer you give, you find it logically with the sorts of stuff that you've learned. As long as you do that, you'll be fine. I think you can quote me.
Is that literature research, or is it just, do we have to look at the literature as well?
I mean, only in so much as you know what you're doing. It's not like they'll expect you to go out and write a dissertation on the assignment research. It should be pretty self-contained. So if you know how to analyze the data set, right, based on Sebastian and Fidel, or based on the class notes, those should be the only resources you're going to look at, at least in my experience with these assignments. You can't put me on that one, because you could always throw a curveball that I'm not expecting. But that's what I would imagine will be true.
Yeah, the questions do.
And is it related to what
I don't know what it's related to necessarily. Is it related to the thing that's due?
What are we? So I think this means that it's related to the times two squared. I don't know what we do on this one because it might get assigned on that. But that's my understanding. I don't think they'll assign any homework on these previous topics. I think they will assign a topic or homework related to that. But
We'll find out.
yeah, you guys are gonna find out, and I'll find out when I get classwork.
I also have that some of them are if we do a group project, maybe join some of you because I don't know. Yeah, just I mean maybe we will find that when there's some questions coming up.
I think all of our emails are on my email. Like the one that you sent us. So we can just like email and with projects too.
Yeah.
Okay.
I don't have anything else, so technically we're here till 5. If you guys have questions, you have 19 minutes to ask them, but don't feel like you have to stay if you don't want to. Once you guys, yes, I will post this. I'll make a slightly neater posting on what I just posted. So instead of it just being that download that we used, there will be a folder there. It'll have this PowerPoint and the dates that we use. That's all I got.
Is so when you look at the coefficient for Becker and Pilot and constant,
Yep.
and you're trying to figure out who scored highest,
I got it.
here it would be Pilot.
Yeah, and this can be used for that, which is what I was using it for, right? So this tells us that the Pilot score is 29 points higher on average than whatever we're comparing it to, and same thing for Piker. But truthfully, just because I never want to misinterpret the output, it's kind of nice just to be able to run the descriptives on their own. So I guess we'd have to do it as a crosstab. So if we did descriptives, crosstabs, and if we said rows are codes and scores are columns or something like that. That's not what I wanted. Give me a second. The short answer is yes, but maybe I'm thinking about this wrong, but I think this should work. No. All right, I'm thinking of something else. Might have to get back to you on that one. I'll think about it for a second. There's definitely a way that we can run. Oh, that's how we can do it. All my SPSS skills are coming back to me slowly. It's been a minute. So under data, what we can do is we can split the file, and we can split it by our code variable. So organize output by code, and say okay. And then if I go to analyze descriptive statistics, descriptives, and take my score variable, then it should give us output organized by our 3 different codes. So, you know, again, just to make sure I don't misinterpret my output, this tells me who has the highest mean, who has the second highest mean, who has the third highest mean. Doesn't tell us any significance tests, right? That's what we did earlier. But this tells us the directionality of the thing. So if we find